Hi everybody, welcome back. As we continue to talk about basic concepts in statistics, this time let's focus on distinguishing between different types of variables. You'll remember in a previous video, we talked about measurement, and measurement just really means we're going to assign some value to an object. And when we're measuring different objects, the values that we assign can indeed vary. That's why when we measure things, we typically talk about measuring variables. So when I'm trying to learn about people, I might measure a variety of different variables. I can measure your age, and of course that value is going to vary between people. I can measure how many friends you have. That number is going to vary between people. I can measure how much money you make, and that value is going to vary between people. Most things that we're interested in measuring are indeed variables. Every now and then, though, we come across something that we measure that does not vary in its value, and we call that type of measurement a constant. Let me give you an example that puts a variable and a constant together in the same context. In a few weeks, all of my students will be taking an exam, and exam scores are going to vary. Some students will score very high, and some students will score lower. So the actual exam scores will clearly vary. But let's say something happens. I realize that the exam wasn't completely fair, and I decide that I'm going to give everybody 5 extra points tacked onto their score. Do you see how in that case the extra points do not vary? Every single student will be getting 5 extra points. So that would not be a variable, that would be a constant. Okay, no big deal. Just wanted to make sure you understood the difference. Let's spend the remaining time in this video talking about how we can distinguish variables. We'll talk about distinguishing variables on a continuum. We'll talk about distinguishing variables that we use in an experiment. And we'll talk about how we can distinguish between variables that are used in a correlational study. First, let's talk about distinguishing variables on a continuum. In that context, we can think about variables as either being discrete or continuous. Let's first talk about discrete variables. One way that you can think about discrete variables is that they represent indivisible categories. In other words, only whole numbers would really make sense. So think about the number of kids that a family might have. A family might have no kids, or 1 kid, or 2 kids, or 3 kids. But unless you overthink things, there's no family that has 2.5 kids. And that's because when we're measuring the number of people, in this case kids in a family, that represents a discrete variable. Only indivisible whole numbers make sense. Another way to think about discrete variables is that they are countable because they have relatively few categories. And you might actually want to put few in quotes because there might be a lot of categories, but my point is that the categories are countable. So if I'm trying to measure how developed, how mature a city is, I could look at all of the buildings within that city and count the number of floors in each building. In this situation, the number of floors contained within a building would be a discrete variable for a couple different reasons. First of all, we have indivisible categories, as I mentioned before, because there can be 1 floor or 2 floors or 3 floors or 100 floors, but there can't be 97.5 floors. Unless we overthink things, that doesn't really make sense. And when I mentioned that discrete variables have few or countable categories, my point was that we could count the number of floors. So sometimes that count would be very quick, 1, 2, 3 floors. Sometimes that count might take us a while if there are 200 floors in a building, but the point is we could count them all. These are hallmarks of discrete variables. Think about if I was measuring the number of times that a person has been married. A person could be married 0 times, 1 time, 2 times, 3 times. We've heard about some people being married 6 times, 7 times. Do you see that when we measure that variable, there's a somewhat limited number of options for responses that we would find? So that's, in general, what I mean by few countable categories. And that example also has indivisible categories because someone's not married 2.5 times. We can contrast discrete variables with continuous variables. And I find continuous variables more fun. They are infinitely divisible. And what I mean by that is that you can find valid data from the lowest point on the number line to the highest point on the number line, including every single point in between. Think about something like distance if we're measuring that in miles, let's say. I can say that I live 20 miles from where I work. If I'm measuring something like miles, it would represent a continuous variable because I can continuously break down that measurement into smaller units. So it might be 20 miles, it might be 21 miles, it could be 21 and a half miles, it could be 21.94732 miles. Do you see how we can keep getting more and more and more precise when we're measuring miles? In other words, when we're talking about continuous variables, fractional components make sense. Think about a person's weight. If we're measuring a person's weight, we can break it down into fractional components, and those components make sense. Let's talk about measuring weight in terms of pounds. A person could weigh 150 pounds, 151 pounds, or any point in between. For example, 150.5 pounds is indeed a valid measurement, and 150.543 pounds is a valid measurement because I can keep getting more and more and more precise, and I still have valid measurements. Time would be another thing that we can measure that would represent a continuous variable. So how long does it take you to drive to school? It might take you 10 minutes, 14 seconds, and 33 milliseconds. That's a valid measurement. It's a little strange to talk about your drive time that way, but it is indeed a valid measurement because we're talking about a continuous variable. So why does this matter? Remember, we talked about having to understand the type of data we have so that we can see what's the most appropriate type of statistical analysis. Think about your work schedule for a minute. Maybe on average you work somewhere around 15 hours per week. But if we were to actually really crunch the numbers and we compute an average, it would probably be something like 15.43 hours per week. A number like that really only makes sense when we have a continuous variable. Let's move on and talk about distinguishing variables in an experiment. A lot of students, until they take a class like this, use the word experiment in a very general sense. But an experiment is a very specific thing. It's a very well-controlled thing. And in an experiment, there are two primary variables that we want to think about. In any experiment, we always manipulate something. And the thing that we manipulate, we call the independent variable. In this example right here, we were putting people either in a comfortable room or in a really hot room. And then we were trying to get them to remember some information. We wanted to test to see if the temperature of the room would have an influence on how much information they could recall. So we call that the independent variable. The dependent variable is that main thing that we measure. So I want to see how much information they can recall. Here are their scores on that recall test, on that memory test. We call that the dependent variable. So when you think about an experiment overall, we manipulate an independent variable to see if it has an effect on the dependent variable. I find that students always get those terms mixed up, independent and dependent variable. Let me show you one way that I distinguish between them. Assume for a minute that you are the experimenter, that you are the researcher in this study. In that case, you independently get to decide the temperature of these rooms. So it's the independent variable. And then you want to see if these memory scores depend on the temperature of the room. Thus, they are the dependent variable. So that might help you. But that's just part of what makes an experiment really special. Here's the key thing right here. Everything else in an experiment is controlled. That word control is so important, and we're going to talk about it in a little bit more depth in just a minute. How do we control things? We control things via random assignment and just general common sense. Let me explain. When I say that I want to have control in this experiment, what I'm really saying is that I want this group in the comfortable room that I'm going to compare with this group in the hot room to be as equal as possible at the beginning of the experiment. In a good, simple experiment like this, I want only one thing to vary between these two groups, and in this case, it's simply going to be the temperature of the room. So how can I exert that type of control? How can I try to hold everything else constant? Well, the very first thing that I'm going to do is randomly assign people into each one of these rooms. So when people start to show up for my experiment, and I've got these two rooms on either end of the hallway, I need to determine who's going to go into the comfortable room and who's going to go into the hot room. And what I'm going to do is literally something like flip a coin. If I flip a coin, then each person has an equal opportunity of either being in the comfortable room or the hot room. And this is why it's important. Think about people who show up on time. People who show up on time and are prepared, they might be a little bit smarter. If I took all of the people who showed up first and I put them in the comfortable room, and then I took the people who showed up later and I put them in the hot room, if later on I found that the people in the comfortable room outperformed the people in the hot room, it might be because of the temperature of the room, but it also might be because there are smarter people to begin with in the comfortable room. That's a problem. That makes the experiment hard to interpret. So I need to control for that. I need to make sure that these groups start out approximately equal. And how can I efficiently equalize those two groups? I can via random assignment. If I randomly assign people into one of these two rooms simply by flipping a coin, they should start out approximately equal. I will have equal numbers of smart kids in each room. I will have equal numbers of problematic kids in each room. I will have approximately equal numbers of women in each room. I will have approximately equal numbers of psych majors in each room. If we have a large enough sample size, a simple random procedure will essentially equalize the two groups. So that's one way I'm going to control this experiment. The other ways are relatively obvious because they're more based on common sense. For example, if I want to see how much information they can remember, I want to present the exact same information to these two groups. And if I'm going to let them study that information for an hour, I want to make sure that each group has 1 hour to study. If after 30 minutes I'm going to give this group a break, I've got to make sure after 30 minutes I give this group a break. So my goal is to have both of these groups sit through the exact same situation, except one thing. These students are in a comfortable room, these students are in a hot room. And here's the really important point. If the experiment is controlled appropriately, those two groups will differ systematically simply based on that one independent variable. This is what makes an experiment such a special thing. It's only through experimentation that we can isolate and test the effects of one variable. If I find differences between these two groups, if I find that the people in the comfortable room outperform the people in the hot room, I can say with confidence it's because of the temperature of the room. The reason I can say that with confidence is because the temperature of the room is the only thing that systematically differed between those two groups. You might be a critic and you might say like, yeah, but isn't it possible there were just smarter students in that room? And I'll say, no, that was very unlikely because I randomly assigned the students to the rooms. Or as a critic, you might say, yeah, but isn't it possible that the students in this room just had easier information to remember? And I'd say, no, I controlled for that. The students in the comfortable room and the hot room were studying the exact same information. So when carried out correctly, experiments can be brutally efficient. We can learn very quickly, like in this case, if some variable, like the temperature of the room, actually has an effect on learning. But in the real world, there are some things that we cannot fit into an experiment. There are simply some things that we can't control so precisely. And that's where correlational research comes in. Let's talk about that next. You're going to see that in a correlational study, you don't have nearly as much control as you would have in a true experiment. I'm a social psychologist, so we'll look at an example from social psychology. Here we might be asking this type of question. Does watching violent TV have an effect on a child's aggressive behavior? In other words, I want to see if there's a correlation between these two variables. So we have two different variables that we're looking at. One is the number of hours of TV violence that a child watches per week. And another is some type of measurement of aggressive behaviors that the child behaves in, like for example at recess or maybe throughout the day at school. You can see that of these two variables, what really makes the most sense is that we're trying to see if watching TV violence might be able to predict a kid's aggressive behavior. That's why in this situation, we would call the amount of TV violence that they watch per week the predictor variable. Some people will call that the independent variable or the quasi-independent variable. It's kind of like an independent variable. But in reality, at least for our class, independent variable is a term that we're only going to use in the context of an experiment. So in a correlational study, we would call that the predictor variable. So we want to see if the amount of TV violence that they watch might predict their aggressive behavior. Some people would call this variable, their aggressive behavior, the dependent variable. But just like I said previously, I think that term is best used in the context of an experiment. So in the context of a correlational study, we would call aggressive behavior a criterion variable. The terminology is important, but really the more important point that I want to make is that in this type of study, we're not manipulating anything. In this type of study, we have very little control. In the real world, I don't have control over how much TV violence a child watches. All I can really do is measure it. And when I'm measuring their aggressive behavior later on throughout the day while in school, again, I don't have all kinds of control over what's going on because they're involved in an actual school day. Correlational studies allow us to measure some things that we wouldn't be able to measure otherwise in an experiment, but it comes at a cost. That lack of control comes at a cost. We might find, for example, that the kids who watch quite a bit of violent TV, they do act more aggressively. And kids who watch very little violent TV, they act much less aggressively. In other words, we might find a positive correlation between these two variables. In this situation, a positive correlation means that as one variable increases in value, the second variable increases in value. So kids who watch more TV violence, they tend to act more aggressively. Now the flip side of that would be kids who watch very little TV violence, they tend to act less aggressively. That is an example of a positive correlation. And we would love to be able to say that watching violence causes aggressive behavior, but it would not be appropriate to draw that conclusion. So the question is, why can we determine causation in an experiment, but we cannot determine causation in a correlational study? Well, I mentioned because correlational studies are not well controlled, there are always other alternative explanations that we can't rule out. It's possible that the relationship between these two variables actually runs in the other direction. It's possible that kids who are aggressive, they're really interested in violent, aggressive TV. So watching TV violence isn't causing them to be aggressive, but maybe being aggressive is leading them to watch TV violence. My point is that we have not ruled this out in this study. We don't have enough control in this study to rule that out. There are also many other variables that we can't rule out. For example, kids who are aggressive might have aggressive parents, and their aggressive parents might be more likely to watch violent TV. So these kids might act more aggressively because they learned it from their parents, not necessarily because they're exposed to more violent TV. Do you see how complicated things get with a correlational study? Because we lack the control of an experiment, it's very difficult to interpret causality from a correlational study. Now, this is very important. Don't misinterpret what I'm saying. I'm not trying to tell you that correlational studies are worthless. The bottom line is that there are many things that are very important to study that we cannot control in the context of an experiment. And ultimately, if we want to learn about those topics, we will need to study them within a correlational design. Well, I think that's about it for now. I hope you found this discussion interesting. The next time we get together, we'll talk about some different methods for finding a random sample that we could use in an actual research study. In the meantime, be safe.